Good morning. We're going to do a single problem. I'm having a theme today. The theme is laboratory procedures. So we're doing that in class. You've already had it. Most of you actually. It's a larger class. And then I'm going to kind of follow it up with this question as well today. So this is a really good one. So the student is given the task of determining the I minus or the iodide content of tablets that contain Ki and an inert water-soluble sugar as a filler. A tablet is dissolved in 50 mils of distilled water, and an excess of 0.2 molar lead to nitrate is added to the solution. Yellow precipitate forms, which is then filtered, washed, and dried. The data from the experiment are shown in the table above. So basically, you had this solution. Okay, you added some PbNO3, and you ended up getting a, let's say the actual color, a yellow precipitate. And that yellow precipitate then is dried and filtered and dried. Okay, so that's kind of where we're going with that. So you have to kind of keep in mind what the precipitate is. It initially had Ki in it. Okay, so you should be able to kind of see what's all happening with that. So AI. So write a balanced net ionic equation for the reaction. So I have given you the two compounds. One's in green, one's in black. I want a net ionic. So let's do a reminder on this. Net ionics for precipitates ultimately make a solid on one side, right? And on the left are the ions that make that solid. If you're not sure, you can write it all out. You could totally do this. And then you could start making it. But eventually, a net ionic means that there could be spectator ions that need to be crossed out. That's what that means. So please, give it a shot if you've not already done it. Give you about 45 seconds. Tell me now, when I look at that, the way I've written it in my red, is that all I do is I think about what the solid's going to be. So you should really know what that is. You can actually write it first if you'd like. Remember, solids, gases, liquids stay together. Ions are things in solution only. So what makes those solutions? Those two ions, right? One little mistake? Or I haven't finished? I need to balance charges and elements. So there's a zero charge on the right, so it has to become a zero on the left. No, that's it dissolves though. Tablet contained inert, well, tablet is dissolved. Yep. It was a solid. All right, double I. Explain why the reaction is best represented by a net ionic equation. Now, this is hard because it's like, how am I supposed to say this in words? But basically, what you could be generalizing this too. In general, what are we not showing? We're not showing the spectator ions. Those are not, if you need to have an extra explanation, spectator ions are not part of the active chemistry. Right? They're not involved in the chemistry. Chemistry is making something new. If you have Ki on the left and you have Ki on the right, nothing has been changed with that. There's no chemistry actually involved in that, per se. The net ionic equation shows the formation of PbI2 from Pb2 plus and I minus ions, omitting the non-reactant species, spectator ions, K plus and NO3 minus. So that sounds more complicated, the question, than it actually is. It's basically, you're not showing the spectators. Which I would just say, which are not involved in the actual reaction. Okay, those are both one point. Letter B. Explain the purpose of drying and weighing the filter paper with the precipitate 3 times. Talked about this in class actually today, and we've talked about this a little bit over time. Why are you doing this? Why are you drying and weighing the filter paper with the precipitate 3 times? To make sure all the water has been evaporated, right? All of it is gone. If the mass continues to change, that means going down, that means something continually leaves. Whenever any solution is, reaction is being done in the context of water, then you don't want that as a final mass. So you have to continue to weigh that. So you'll see the numbers, 1.775 to 0.699 to 0.698. Because of those last two, it's leveled off. So filter paper and the precipitate must be dried several times to a constant mass to ensure that all the water has been driven off. You want to make sure all the water is gone. One point. Okay. In the filtrate solution, so in my picture, in pictures, if you don't know what you're reading at all, draw a picture, try it. Is the concentration of K plus greater than, less than, or equal to the concentration of NO3 minus? Justify your answer. Okay, so first off, there's only one place that they gave us some numbers, so that is a little tricky. They said it was 0.2 molar PbNO3, 2, but that is not the make-all, be-all of this. If you wrote this all up, I'll let you think about that for a second, but if you wrote these all out as ions, every one of them, that would probably be very helpful. Let me show you. Because I have that written right there. Now, I haven't finished it all up. Anybody have an idea of which one is less? Or not less, if K is greater than, less than, or equal. I got to answer it in terms of the question. Yeah, Morgan, what do you got? Why is that? They both have a 2? Are you saying because when you balance it like this? Right? Is that what you're saying? Okay. Glad you brought that up. Those coefficients are ratios to each other. But the actual ions that come off, that's where the concentration originates. I'm going to give it away right now. Boom. Because there's 2 NO3s that came to the party in the ratio versus only 1 K, there has to be more NO3. So the answer is K plus, concentration of K plus. Now, if you had extra values to work with, then you would have to manipulate that and work with that. Another way to actually go about this as well, guys, I'm just looking at this because I'm struggling a little bit with the idea that there's no extra numbers. You might want to circle that. The fact that there was also an excess, meaning you have more than you need, that actually means then that right away, even if it was a 1-to-1, I'm looking at the 2 because I think that's the part that I think people would overlook. But even if this was a 1-to-1, the fact that this was an excess, we put more of it than we need in the reaction. That makes sense? So right there, that is the other clue that you get. So 1 point as well. Most of these are all 1 point. Okay. As I was saying to the first hour today, I'm almost done grading your finals. They should be done by tomorrow. We'll go through it in large group. They're very good so far. But people were struggling with things like D and E. So we're doing one in class today, and we're doing one right now as well. So it says calculate the moles of the precipitate that is produced in the experiment. So I want the moles of the precipitate. So ultimately, I need moles of PbI2. So that means you probably have some data. So looking up at the data, what am I going to do? If you ever have moles, you might always, like if you have data that's given in grams, then you first need to figure out the grams. So let's call it 1, 2, 3, 4, and 5 again on there. What am I using? 5 minus 2, correct. You take the last final mass, because that's the one that you know is good, and that's of the filter paper and of the PbI2, of the precipitate, and you're going to subtract just the filter paper. By the way, I don't think do they go all the way? They never actually tell you that PBI2 is the precipitate, so that's knowledge you need to have. You need to figure that out, unless I'm totally missing it, but I don't see that. And then I want to get moles, so hopefully we're good with that. Struggle with that a little last hour. All right, 1 point. I thought it would be 2. There are problems with sometimes just if you're able to interpret the grams, you're good to go. Well, we're going to use that. You're always going to use it. And these problems, they're building you up. They're trying to get you information, unfortunately. So if you struggle at one or you could not get it at all, just say assume something. Assume 0.5 moles of PBI2. The reason why you're probably going to need it on the next problem. And my suggestion to you is if you're going to skip it and you go to the next one, you're like, man, I kind of felt like I know how to do this if I knew what that value was. That's where then you have to establish that, well, assume this, and I'll use it from there. Calculate the mass percent of I minus. All right, this is where everybody starts to fall apart. I want the mass percent of just the ion. So you got to break this down. What you need, you guys, you need this. You're going to need grams of I minus over the total grams, right? So in the tablet. So this is what you need. I like to actually think about the actual units of what I'm going for before I start. Otherwise, that gets really difficult for me. Okay, so where is the I minus coming from? The only stuff that I know, because I don't know anything about the tablet, all of the I came out from the tablet into the precipitate. So I got to use what I just had. So I'm going to use this. Stay with me. This hopefully will make some sense. For those of you that don't have class yet and it's coming up, this will actually help you with the problem we're going to work on. If I want to get to moles of I minus, you need to do a ratio. You're already in moles, so now you can do mole ratios. For every mole of PBI2, how many moles of I minus do I have? 2. That's how it works. And then from there, I can actually get into grams right now. So what do? You're going to take the 0.130 grams of I minus and what are you going to put it over exactly? 0.425, right? It's the grams of the Ki. 2 points, one for the, bless you, actually just the moles, that's weird. One for just getting to this. I didn't solve for that, I continued on. The answer key actually started here and then they did another step. I don't know why you need to do that. So that's 2 points. All right, finishing up, we have 3 last questions. 3. In another trial, student dissolves a tablet. So this is what they do. They make you do calculations, and now they're like, hey, let's just twist it up a little bit and see if you still understand what the heck is happening. Dissolve the tablet in 55 mils of water instead of 50. Predict whether the experimentally determined mass of I minus would be greater than, less than, or equal to the calculated amount in part E. Justify your answer. We don't have a lot of time to talk about this. Sometimes it's confusing. It's like, wait, sometimes it's less, sometimes it's more. Okay, you got to realize how that affects it. So if all of a sudden, let's take a look at my picture. If I just take my water level, and I just raise it up, what's that going to do to my tablet, or the I in the tablet? Now, here's the trick. You didn't have, more couldn't dissolve. You dropped the tablet in, you brought the amount of I and K already in there, right? And then you put in a ton of extra PBI or PbNO3, and it brought out the I. It didn't matter if that was in the ocean. That is the amount of I that's going to come out because that was in excess. So it's going to be the same in this case. And on your final that we did, there was one that actually was not that. It was actually less, and we'll talk about that one tomorrow. So it was less. It'd be the same. Sorry, I'm saying the wrong words. Because the precipitate was the same amount of precipitate no matter what. Right, the mass of I minus will be the same. Pb2 plus was added in excess, ensuring that essentially no I minus remained in the solution. The additional water is removed by filtration and drying, the same mass of dry precipitate. I'm sorry that I'm not thoroughly writing that out, but I want to make sure we get all this. Final two quick. A student in another lab also wants to determine I minus content of Ki tablet, but does not have the access to PbNO3 2. However, the student does have access to AgNO3, which reacts with I minus to produce AgI. The value of KSP for AgI is that. Will the substitution of AgNO3 for PbNO3 result in precipitation I minus ion from the solution? Justify your answer. Yes. Why? Because it precipitates. And if you had to justify, what does it mean to have a really low KSP? It means it's insoluble, so it will precipitate. So that's why they gave you that number. You're like, why did they give me this number? Because it's a low KSP, it will precipitate. Now, whoa, some of you already know. What the heck? Some of you already know that that AgCl is a precipitate.
Students, just a reminder that today is the last
student
day
only
prom ticket.
Prom, make sure you go to prom. They're short like 200 tickets right now.
$25.
That have not been paid. It's crazy.
Your meal. Thank you.
I kid you not. You have to buy prom tickets today. Like, they are short by like 200 tickets from normal. Student only has access to 1 Ki tablet and a balance. Casey, you may not be going. And a balance that can measure to the nearest 0.01. Will the student be able to determine the mass AgI produced the 3 sig figs? Justify your answer. Guys, if it only goes to 0.01, what was the mass of the grams of it? So if it were this, if you had something like this, that's 3 sig figs, right? But the thing is, we were less than that. Our masses, all of our masses are point whatever. So the value only goes to 0.01. That stops right here. So no, I cannot be accurate enough because the values will not show 3 sig figs because of how small the measurement is, if that makes sense. Again, if it were, I'm sorry, I'm rushing this now. This was 3 sig figs. If I have to do this, that ends right there. I'm done. I can't get 3 sig figs. So if my value is too small, I can't get 3 sig figs. And that's just one point as well. So that is all.